Hi everyone, it's time to do another Leetcode problem, and today's problem is problem 141, detecting a cycle in a linked list. So basically we are given a linked list. That means we're given the head of the linked list and we have to find if there is a cycle in it. So what is the definition of a cycle? So there is a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. So as you can see from 3, the next pointer you go to 2, then next is 0, next is -4, and from -4, the next is again -2. So you're visiting 2 again. So there is a cycle. Similarly, you visit 1 and then follow the next to 2, and from 2 we revisit 1 again. So you're coming back to the same node. So coming back to the same node means there is a cycle in it. But if you cannot do that, then there is no cycle in it. For example, in example 3, from 1, if you follow the next, you reach the null. So any list where you just follow the next, and at some point you hit the null, then you have to say that there is no cycle in the list, and you return false. Okay, so the main idea is just if you are revisiting, if you reach the same visited node again, then you have a cycle in it. So as always, I suggest everyone to think about the solution and then come back and resume the video where we can discuss the solution together. Okay, so by now you have got the idea that a linked list has a cycle if I somehow revisit the node by just following the next pointer, right? So in this case, you see by just following the next pointer, we revisit this node 2. So why don't we keep a hash set, say call it visited, and every time we visit a list node, we just make an entry in the set so that next time if I revisit it again, I can just check this visited set and see, oh, okay, this node was visited in the past, so there was a cycle. So for example, here, this is the head that was given, right? So we start visiting from here. Initially, there is nothing in the visited list. So we make an entry for this. Then we visit this, the next node. The next node is 2, right? So we check there is no entry for this node. So we add it to the node. Then we visit 0. There is no entry for this node. Next, we visit -4. There is no entry for -4, right? Okay, so next we visit 2 again. Now I check and see, oh, okay, this node is already visited. This node is already visited. That means, yes, we have hit a cycle, so we return true, right? Okay. So when do we return false? Obviously, we return false if there is no cycle. That means that list ends with a null. So for it here, you see that I visit here, right? Let's just do the same thing. So say this was 3, 2, 0. Okay. So I add 3, then I add 2, then I add 0, right? And then I reach null. Okay, so I hit null. So you see that if I hit null, then I say return false. Okay, so what is the time complexity for this algorithm? As you can see, we are actually, to detect a cycle, in the worst case, we are just traversing, say, we are just moving our pointer n+1 times, right? So it's order of n. And the space complexity, you see, we have this extra hash set. And in the worst case, we are adding all the nodes, that means n nodes in the hash set. So the space complexity is order of n. Now, can we do it in a smarter way? Can we do better? And as you can see, here is a follow-up problem. It says, can you do it with constant memory? Okay, so let's talk about another smart technique of detecting cycles. And we are going to use this technique in many other problems. So this is called like having a slow pointer and the fast pointer, right? So the slow pointer will actually move one place at a time, whereas the fast pointer will move 2 places at a time. Okay, so there is the fast pointer and the slow pointer, they will either move away from each other or they will close the gap between each other. I'm going to show you an example and it will be more clear. So let's start with the example, the first example that they have given us in the problem. So this was the example, right? And then the next point was pointing to this. So initially the slow and the fast, both of them were here. And I move the slow pointer one place at a time. So the slow pointer goes here and fast pointer goes here, two places at a time. So here and then here. And then I move slow pointer one place and the fast pointer two places. So fast pointer is here and here. So as you can see, the fast pointer was actually increasing the difference or the distance by 1 so far. Now the thing is reversing. So you see now the difference between the slow and the fast pointer is now 1. Next time the slow pointer is here and the fast pointer actually it reduces the difference, it moves here, right? So the difference between the fast pointer and slow pointer either increases by 1 or decreases by 1. So what it ensures that is, since it's increasing by 1 and then at certain point, if there is a cycle, it's decreasing by 1, the fast pointer is actually catching up the slow pointer and then they will collide at some point. So if, at some point, if the slow becomes the fast, then we say we return true. Okay, it's simple. Okay, and now when do we return false? So we return false if there is no cycle, obviously. So you see 3, 2, 0, and -4. For this one, say next one was now, right? Okay, so the slow would have been here, fast would have been here at the beginning. First step, slow is here, fast comes here, right? Second step, slow comes here, fast comes here, okay? So if fast becomes now at some point, then we return false. Not only that, we also have to check, say, if we had like odd number of nodes. Let's see what happens now. Slow is here, fast is here. First step, slow moves here, fast moves two places. Next time, we don't want to repeat this thing one more time because as you can see, it's already pointing to the null. So if I try to jump 2 steps, we will have a null point exception, right? Okay, so there is no next to this. So we also have to check if fast is equals to null. So, or if fast dot next is equals to null, right? In both cases, we return false. Okay, so what is the time complexity of this algorithm? As you can see, in the worst case, we are actually increasing the distance, reducing the distance, and then at some certain point, we're meeting each other, the slow and fast are meeting each other. So what is the maximum difference they can have between slow and fast? N, right? And how much time extra will take if I want to reduce that difference to collide with each other? N, right? Okay, so say in the worst case, I am moving not only in places, I am also reducing the distance. So in the worst case, the time complexity is going to be order of n. That's including traversing the nodes as well as if there is a difference at some point, reducing that distance or difference so that they collide with each other. So the time complexity remains this. And the space complexity, as you can see, we are not using any extra space. So the space complexity is order of 1. So let's check the code. We check if the list is already null or the list has just one element. In that case, we return false. We cannot have a cycle with a list within a list that has just 0 or 1 element. Then we set both the slow and fast nodes to head, and we keep on checking if at certain point is fast is null or the next of fast is null, then we just get out of this while loop and return false. Otherwise, we move slow by 1 and fast by 2 places, and then check if the fast and slow is pointing to the same node. If that is the case, then we return true. So we keep doing this inside the while loop, and once if the while loop is broken at some point, then we know that we have hit the null. So we return false. Okay, so that is it. If I submit, you can see that this is quite fast. It beats 100%. So thanks everyone for watching, and we'll come back with another problem next time.